In this lecture, we will learn to construct DFA. So the first question is to design a DFA which accepts all strings over the alphabet 0, 1, in which second symbol is 0 and the fourth symbol is 1. And the next question is to construct a DFA which accepts a language of all binary strings divisible by 3 over the alphabet 0, 1. So let's start with the first question. So moving on to the first question. So in the first question, it says that second symbol is 0 and the fourth symbol is 1. So it specifically states that second symbol is 0 and the fourth symbol is 1. So minimum length is equal to 4, assuming minimum length is equal to 4, and let the strings are. So first symbol, there is no restriction about the number, so it can be either 0 or 1. And the second symbol is 0, and the third symbol, there is no restriction about the third symbol, so it can be 0 or 1. And for the fourth symbol, it says that it should be 1. So this is our first position, this is our second position, and this is our third, and this is our fourth. So second and fourth are fixed, and it says second should be 0 and the fourth should be 1. Okay, so this is the condition. So let's start with the transition diagram. So we need an initial state Q0, Q1, Q2, Q3, Q4, and Q4 is the final state, and we might have a dead state. We might need a dead state. So let's arrange the state. So this is our Q4, this is our Q3, Q2, and Q1 state. Okay, and this is our dead state. Now let's label the state. So it's Q0, and this is Q1, and this is Q2, this is Q3, and the next is Q4, and this is Qt. Okay, now let me increase the size, otherwise it will not be visible enough to see. So I made 36, this to 36 as well. So all the labels change to 36, 36, 36, this to 36 as well, and this to 36. Okay. So these are our labels. Let's so QD, this is your Q0, Q1, Q2, Q3, and Q4 state. Okay, now let's draw the transition. Okay, so Q0 is our initial state. So from Q0 to Q1, I can have either 0 or 1. And Q1 to Q2, it is compulsory that it should be 0. If 1 is coming in between, I should send it to the dead state. Okay. And Q2 to Q3, there is no restriction. It can be either 0 or 1. And Q3 to Q4 should be 1. From Q3, is there any other than 1 comes? So I am sending to dead state. And in the fourth symbol, there is no restriction about any number of occurrence of zeros and 1 possible. Any number of occurrence of zeros and 1 possible, and it can be a self loop. And for QD, according to the rule of a DFA, every state should consume all the inputs. So that's the end of the transition diagram. Now let's verify. Now let's verify the string. So let the string be checking. Then checks the string as 0 0 1 1 0 0 1. Okay. will say Q0, 0, I'm moving to Q1 state, and Q1 to 0, I reached Q2, Q2 to 1, I'm in state Q3, Q3 to 1, I reached Q4 state, and Q4 to 0, I'm in Q4 because it's a self loop. So Q4, Q4 again with the 0, I'm still in the Q4 state because it's a self loop again, and with 1 as an input symbol, I'm still in Q4. So Q4 is the final state. So this is a final state. So obviously this string, this string is accepted. How do we check whether the string is accepted or not? The second symbol is 0 and the fourth symbol is 1, and this is according to the rules. Obviously it should be accepted by the machine. Okay, now let's check another case. Suppose the string is 0 1 0 0 1. Okay, let that string. Okay, so it's Q0 with 0, and I reached Q1, and Q1 to 1, I reached Q1 to 1, I reached QD. So QD is it does not have an outgoing state, it's an incoming state. So now I'll be in the QD, I don't have any forward transition. So I'll remain in the dead state. Q0, QD 0, I am in QD, QD 0 again, I am in QD, and QD 1, I am still in QD. QD is a non-final state. It's a non-final state in M. So if it is a non-final state, means this string will not be accepted. This string is rejected. Okay. This is the NFN, and this string is rejected. Okay. So in the first condition it can be 0 or 1, second symbol it should be 0, and fourth symbol should be 1. So here it is 1 and the other one is 0. So it should not be accepted by the machine. Now let's move to the next question. So the next question, it says all binary strings divisible by 3. So whenever such question comes, what you have to do is you have to find the possible remainder for this. So since it is divisible by 3 means you get the remainder as 0, and for the next it is 1, and for the next it is 2. Okay, so you get a remainder 2 and 1 and 0. And let's name this as, let's name the states as, if we are getting a remainder 0, let the state name is Q0 and the other one is Q1, and if it is 2, it will be Q2. Okay, so if I am getting a remainder 0 means I am in the state Q0. If I am getting a remainder 1, I am in state Q2. If I am getting a remainder 2, I am in state Q2. Okay, so this is the condition. Now, how do we calculate the transition diagram? So there is a formula to calculate the transition function. So delta Q0, 0, delta q00 is equal to, equated by using the formula, 2 multiply with the state number plus input symbol is equal to, so 2 into state number is 0 plus input symbol is 0, so it will be 0, so it's in the state q0. So delta transition of q0 with input symbol 0, I am still in the state q0. This is what it means. So this is the formula, 2 into state number plus input symbol, I got a transition q0 0, I reach q0. Okay, so the next question, so the next transition is with respect to one input. So q0 with respect to one input symbol, that would be so moving the state. So state number remains the same, only the input symbol will change. So I'll change the input symbol to 1 over here. So we'll get the number as 1. So the state number will change to 1. Okay. The next case is delta. Now we change the state number to Q1 state. So Q1 with respect to 0 inputs and delta Q1 with respect to 1. So paste. Now I'll arrange. So this is the, so I change the state number to 1 in this case. So it is 1, so 2 into 1 is 2, so the state number is 2 now. So here we changed state 1 and input symbol is 1, so 2 into 2 plus 1, that is equal to 3. So 3 mod 3, when you get 3 you have to divide it again, divide by 3, so 3 mod 3 is equal to 0, so I am in state q0. Now delta q2 comma 0. Okay, it won't be registered, so I'll change again. Q2 so delta q2 comma 0 and delta q2 q2 comma 1. Once I shift that to the other side. Let me prove it down. So I need to draw So delta Q2 equals, and this is equals paste. Paste. So Q2 into state number, I change the state number to 2 here, and the input symbol is 0. So it's equal to 4. So 4 more 3 is equal to 1. So I am in state Q1. Okay, and over here it is state number 2 plus 1. So that is equal to 5. So 5 more 3 is equal to 2. So I am in state Q2. Okay, now let's draw the diagram. Okay, so let's draw the diagram. I need Q0, Q1 and Q2. Okay, so I'll arrange the transition item. So this is my initial state, this is my Q1, and this is my Q2. So reduce the size. Okay. Okay, now let's draw the transition item. So this initial state and the final state are the same. So let's label this as Q0, and this as Q1, and this as Q2. So arrange Q0, Q1 and Q2. So Q0, 0 means when I am in Q0 with 0 as the input symbol, I am in Q0. That is a self loop with 0. Okay. So Q01 means I am moving to Q1 state. Okay. So Q10 means I am moving to Q2 state. Q10 I am in state Q2. Okay. Q11 means I am in state Q0. Q11 I reached state Q0. Then Q20 means I am moving to Q1. Q20. Q21 I am in state Q2. That is with respect to input symbol 1. Okay, this is how we need it to construct. So with respect to the transition function, we draw the transition diagram. Now let's check whether a particular string. So let the value be so 110. Okay, let the string be 110. Let's see whether this string will be accepted by the machine or not. So Q01, I move to which state? I am in Q1. Okay, and Q1 to 1 again is I am in Q0, and Q0 to 0 I am in which state? Q0. So this is a final state. So obviously when I am in the final state means that string will be accepted. So the string, this string is accepted. This string is accepted. Okay, so Q01 I reached Q1, Q11 I reached Q0, and with Q00 I reached Q0, and from Q0 I reached the final state. So this string is accepted. What if my condition is 100? What if it is 100? So binary 100 means is 4, 110 means it's 6. Okay, 6 is divisible by 3, so it should reach the final state. Okay, so this is 4. So let's see whether it is accepted by the machine or not. So let it be Q0. That's it. So Q0, 0, with respect to 1, I reached Q1, and Q1, 0, I'm in Q2, and Q2, 0 means I am in Q1 state. So this is a non-final state. Non-final state. So this string is rejected. Okay, this string will be rejected. Since it's in a non-final state, this string is rejected. Okay. So if 110 is a binary string of 6, so it is accepted by the machine. So delta Q2, if it is 100, that is a binary 4, so it will not be accepted by the machine. Okay. So if you have any query regarding these questions, please feel free to message in the comment box. Thank you.